Hi, everyone. I'm Haley Similar, and we are going to go through the request flow for Blob pushes to the container registry today. Right, and we're probably not going to get into cross-repository blob mounting unless we have time at the end, because it is it's not the usual case, and it's kind of an auxiliary thing. And since it basically skips the blob upload, it's there's not a lot to go over besides the fact that it can happen, which we'll touch on in the normal push. So I'm going to share my screen and we're going to revisit the request flow chart. So if you saw the first part of the video, you're going to get more context because I don't intend to re-explain things, structures within the registry, objects within the registry at the same level of detail, just to move this along because it is a bit more complicated. So this is the push request flow. So in general, we're going to check as the same as every request. Do we support the V2 API? We do. And we're going to head each of the blobs first off. So the client is going to check if the blob is already there. And this is a repository scoped request. So that means that this is the blob on the registry. This is the blob known to the repository and present on the registry. So there's definitely an and there because it's possible that the registry knows about the blob. The repository knows about the blob. It's linked, but it's been removed from the back end. That's very possible. So if the blob's already there, the registry, the client just it knows it doesn't have to push it. Push is expensive, potentially depending on how big the image is. All right, so another thing that can happen is that blob's not there. It's either not known to the repository or it's not on the back end, some combination of the two. And it'll send a 404, we didn't find it. So we're gonna get, so this is where the blob cross-repository blob mount happens. We'll come back if we have time, but let's pretend that doesn't exist. And what we'll do is typically we'll start an upload. We'll do a post to the endpoint. So V2, the name of the repository, blobs uploads. And you're gonna get back from this request an ID, and that's the ID of the upload. So you can delete that upload. You can say, I'm done with the upload. It's not gonna go through for whatever reason. And then you can also upload parts. So you just patch over and over again until you run out of blob to send up to the registry. You can also get the progress of a given upload by its UID. And once you're done, you put to that upload, you use the UID, use the digest. So that can either be the end of a multi-part upload, or it can be the entire upload if the blob is relatively small. And that happens by the client's discretion. So it isn't something that we can communicate back and say like, oh, like if your blob is that big, then don't even try it, right? Do multi-part upload. So the clients do decide whether to try a multi-part upload or not. All right, and then at the end, the client will again do a head request to the blob, and very likely should be there. if everything goes correctly, especially if there were no errors beyond that point. And after all that's done, then we upload the manifest just to put to v2 repository name, manifest, and reference. So that's either a digest or a tag. And there's probably a whole hour of video within that last step, believe it or not. So let's go and look at, so we went over head already in the previous video. It's just the same. There's nothing special. So let us look at post. So I'm going to
The question.
Oh, sure.
When you say a blob, it's always a one-to-one relationship to a SHA, to a digest.
Right. Each blob, everything that's stored in the registry, that's actually data. So not like a tag, for example. Everything but a tag has a SHA hash. Yeah. So there's and blobs are only they only have their SHA hash. There's no other identifiers. So, and they're a tertiary reference to a tag, at least. So, you know, you have a tag that references a manifest that references a blob, or you can have even a tag that references a manifest that references a manifest that references a blob. So there's an indirect relationship between tags and blobs, but typically if you're getting a blob, you're getting it by its digest only. Okay, so I'm now going to share a different screen. We're going to go look at, oh, where is it? What am I sharing? Okay, I just didn't have it up. Okay, well, that's weird. Anyway, so now we're going to look at blob. So blob upload post. So this is not the blob's handler. This is the blob upload handler. So there is a blob's handler, and then there is a blob's upload handler. So this is what we do. And again, for this video, we're just going to focus on the file system metadata. All right, so this is blob mount options, which we're just, that's the blob mounts, the cross-repository blob mounting that we're just going to pretend doesn't exist for right now. So what we do is we start with the repository blobs, and this is the link blob store, which is configured to look at the layers folder under a repository. So it's the link blob store from before. And we called this blobs create little function here. So we're going to see what that does. So we're going to go to the link blob store. We're going to do create. Yeah. So it returns a Blob Writer, which is something we have not talked about yet. And it's very exciting, that Blob Writer. So this is the mount cross-repository blob mounting thing again. So we'll just pretend that we're not doing that. So we generate a UUID. That's the UID for the upload. We generate a started at time. This is used to clean up stale upload data. So there's a function, that'll go around, the process that runs, and it will look around the upload folders that are there because, you know, sometimes they just don't delete the blob uploads. If, you know, something goes wrong, it can just leave stale data behind. So this started at gives that process like some kind of something to work against, like so it's not deleting in progress uploads. All right, so, and this is the path 4 thing. This goes back to the paths.go. So the upload data path spec. So let's see what that actually is. So that is repositories, name, underscore uploads, the ID, so it's uploads ID, data. And then you have the data, so that's the blob. You have the started at, and you have hash dates. So the data and the started at are the important things, more or less. So we've got that path. We've got some white space here that doesn't belong, but that is a very annoying MR. So, oh, it's there too. Oh, that's very tempting for me. I'm sorry to take this diversion, but what does this look like? These are the things that bother me. And you can cut down the length of this too, if you wanted to. Oh, there is nothing wrong with that. Okay, well, hey, do you want to review an MR, Jaime?
Sure.
All right. Because that's egregious. I can't have that.
I understand.
Yeah, I probably shouldn't. That's churn. I'm sorry for this diversion, viewers at home, but I'm not going to edit it out because I don't know how. So here we write the started at file. And then we return this LBS new blob upload. So what is that? And that's just a constructor for the distribution blob writer. So what we do is we get a file writer right from the storage driver. So that's just, that's just a writer. What is that? File writer. Yeah, so this is driver file writer. And it handles like the multi-part uploads. It handles chunked reads and writes. So yeah, and we just have all the configuration passed to here. So it's not a very exciting constructor, but that's all that does. So we're gonna go to the Blob Writer again very soon, but we'll pretend we're not immediately gonna jump to that. So we have the upload, and let's say it's not an error. So we have this blob upload handler. Upload is the upload. Great. So we write the response. We set headers. We return the status. So that just sets it up for the further requests. So there's nothing too exciting about that.
I'm wondering how.
Yeah, go ahead.
So we built that blob writer that is just gonna write the response right now. Right. How do we get it? I guess we're gonna go into that, but how do we get it on the next request?
Oh, you'll see. It's a surprise. Okay. So the reason that we do build it is, let's look at the blob upload response. So not too excited, right? So we build it here so we can get the upload, upload size, there's nothing too exciting here. But we do need it just to write these upload states for now.
Got it.
Yeah. Yeah, so one of the tricky things that I am going to go over this now because it will get you is that this looks like, oh no, you saw the secret before. Start blob upload, right? Nope. Start. Yeah, so there we go. So this is blob upload create, writes data. It does stuff. It will do things a lot more than you think it's doing. It is not just a constructor. And I think it's kind of hard to get into what it does without going into a cross-repository blob mounting, but this is not just a constructor function. So be aware. Yeah, so let's go back to, if you don't have any further questions, we'll go back to the diagram.
I think,
yeah, so we're going to assume this is a multi-part upload because that covers everything. And so we've initiated upload. So let's look at deleting an upload. This is not part of like the regular flow, but it's something that can happen. So I think let's check deleting an upload and getting the status of an upload because they're very short. They're not too exciting. So get upload status. If we don't have an upload.
Still looking at the diagram.
Yeah. Thank you for that. It works on my machine. Okay, I can see it.
It always works on your machine.
yeah. So we get this blah 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 status. Like if the upload's nil, but what we haven't done anything. Like every request is different and special. So we need to look at how we do that. So blob upload, get upload ID. So where does that happen? Validate upload. Okay, so right at the end, that's dispatcher. Oh shoot, how is this happening? I am drawing a blank. I do not know how. I do not know where it is that. Well, we'll find out together. If I've gotten this far without knowing what's happening, it can't be too exciting. So, oh, that bugs me so much though. Basically, we just find it. Blob upload response. And this is the same thing we saw previously. The repository name, upload ID, what's the offset? When did you start the upload? All these, the blob upload URL, like all these things. Yeah, so all of these things you'll just get same as at the beginning, same as at the end of initiating the upload. So look at delete. Oh, we're gonna find that out. That bugs me. But yeah, so if we do find the if we do find an upload, we do cancel on the Blob Writer. So let's see what that is. And cancel. So what do? We do file writer cancel. So we close out the file writer, and we call this remove resources function, which just takes the folder we looked at and just clears it out. So the blob upload data path spec. It's not very complicated. It's just a delete. So it just cleans up after itself. So we have to do it. Git blob upload UID. Okay, but where do you? That comes from the value. Blah.
Looks like some middleware setting it.
I've got to find it, or I'll. I've got to find it. A blob upload handler. Upload. Okay, and so it happens somehow. Structs send. Validate blob up. Okay, well, somehow that happens. I am really sorry to take this. UID, using UID. Since this implementation uses UIDs. Get the UID. Well, it happens somehow. That's your assignment. Find out where that, no. I don't want to take more time. I'm really sorry. It's
I was
okay.
trying. I was looking through the code, but can't find yet.
Registry is a big project. Sometimes these things happen, but this does in fact work. So we're going to look at patching the blob data. And as you can see, if the blob upload handler upload is nil, it will just have this error blob upload unknown, like we couldn't find anything by the UID. Yeah, so content type, some white space doesn't need to be here. Yeah, so we just copy full payload. So this is just an append operation. So the blob writer is a writer interface. So it can just be, we can have a stream of bytes written to it. And it keeps track of its offset. So it just, accrues these over time. And then we can look on this. This is a helper. It's also used with other things as well. But fundamentally, we just do an IO copy. So it's really not that surprising or that shocking. It's a writer, we use it like a writer. Yeah, so then we upload response, same as we've been doing. Blob data, blob upload response, same as it always is. Write the header status accepted. And then we're gonna do complete after that. So we patch. We patch like all the data's up, and then the client will send like, I'm finished. Like that's as big as it is. So we have a digest parameter, and hey, there's no digest. We need one because we're gonna check that digest later. So to make sure that all the bytes came through okay, and that you sent what you expected to send, you being client. So we parse the digest. We copy full path payload again. And this is because this is how you would do a single blob upload. So if you have a very small blob, you'll just do this. You'll just send everything all over at once, but they have to be, I don't know the exact cutoff for Docker client, but they have to be pretty small before they'll actually get single operation uploads. And then we commit. So all of these are a lot of work is done by this Blob Writer. So we really need to look at that because all of these are just coordinating the work of the Blob Writer. So we're going to look at that, and it's a bit hard to it's a bit more complicated than other things in a way. It's kind of hard to like go to particular methods one by one, and like we've done for the link blob store. So so yeah, it just has reading and write methods, what you'd expect. These are not that exciting. Read, write from, close, they're just implementing the interface. They're very, this is just very basic, like low level file reads, offsets, all that good stuff, byte arrays, offsets, you name it, it's that kind of thing. So, and you can see that these hold state, you know, started at the file writer, the driver, all these kinds of configurations. So commit is when, and this is the last step. So you've done all the writing, and either that's your patches or just like one single. Commit is where a lot of the work gets done. So first you'll commit with the file writer, which is a storage wrapper thing, which is just out of scope because they all will do their own thing. So we're closing the writer. We're getting the final blob size. We'll validate the blob, and we'll spend a good portion of time going over that in a second. Then we do this move blob, and that's a very simple move from the upload directory to the canonical path. So let's look at that. So we get the blob data path spec, and that's going to be, this is the blob side of the registry. So the blob data path spec is v2 blobs SHA-256. Then it's going to be the first two hex bytes, and the hex bytes of the digest, then the digest, then the data. So you're under v2 blob SHA-256, you're going to see AA, AB, and onward and so forth until you get to FF. And that is for object storage drivers, they tend to like more prefixes, and that gives you a fair number of prefixes. I think with super, super large deployments, we could really use 2 more, two more digits to play with, but we don't have that. And then the actual hash digest, and then the data, which is just the data, which is normally a tar file, but you will also see just JSON here from the manifests and from the configuration blobs. So that's what that's going to. Yeah, so that's the blob path. That's its final resting place. That's so much nicer. So we stat the blob path. Pretty standard. And this is done with just the storage driver. This is not the link blob store. This is the storage driver directly setting the path. And we want to see that it doesn't exist. If the path already exists, we exit now. And so we don't overwrite things, because writing is more expensive than not writing. But the tricky part with this is if that blob data goes wonky, this process won't refresh it.
So in that case, the client would need to delete it and then upload again?
No, the registry would have to delete it, because clients can't decide. Blobs in common storage, the client can't actually delete them. The only thing the client can do is untag images, delete tags, delete manifest, and delete particular layers from the repository. But the registry may never remove the blobs if it doesn't want to do any lifecycle management. So what would probably happen here is that it'd just be a ticket and there'd be some data repair that happens manually, right? Because even if we do clean up images, there's a delay. If it's offline garbage collection, is that once a week, once a month? It's not quick enough to just let it resolve on its own if there's really a problem here. But we haven't encountered that since I've been here, so apparently it's pretty rare. So that's fantastic.
That's good to know.
Right. Yeah. So we're gonna stat a different path. We're gonna stat the Blob Writer path, and this is the upload directory. So if we don't find this, we need to check and see if it is a zero link blob. That's possible. There's a canonical digest for that, which is this. That's what an empty blob digest looks like. I don't expect you to memorize that, but that's the joy of content addressed to storage. So if there's an empty blob, we'll just write empty space. So if it's not, we'll complain with attempted to move zero link content with non-zero digest. And then new blob uploaded. And then we move. So this is just the driver again. And that's just like take it from the Blob Writer path, which is the upload directory, put it into the blob path. Easy as that. So we've moved the blob. Let's go back to commit.
Is there ever a situation where you say you moved it, but you didn't for whatever reason?
That is, I guess, possible. It would be like an underlying bug in the storage driver. So, and all of our storage drivers are pretty well known. Like they're pretty well known platforms. I think like during the move, you could get a problem. During the move, you could have like a client disconnect, right? But it would need the storage driver to do the move, fail, and just silently fail and just return nil. So it's possible, but that's like a much lower level error.
Yep.
Yeah. So what we did there was we moved the blob into stable storage, right? Into the, well, there was no stable storage before, but we moved it into the, where it's supposed to live long term. That's this content addressable location. Everything is good. What we do now is that we link the blob, and that is just writing that link file. So I won't get into that because it's not too exciting, but that's just writing that link file. And I'll look at it in paths.go. So we have a good idea. So it's just writing this file and writing the digest to the link file. So nothing, oh goodness, nothing earth shattering there. So yeah. So we call that remove resources again. So if the upload is deliberately canceled or it's successful, it will try to clean up after itself, because that's great, right? The upload purger is like, we'll have to do some work on that in the future, but it has some quirks, shall we say. And then we get this blob access controller set descriptor. That is for if we're using the blob descriptor cache. So that's just setting it in the cache if there is a cache. If there's not a cache, then this doesn't do anything. We set the state for the blob writer that it's committed, and we return the digest, the canonical digest. So that's about it. But we didn't go through the validate blob step, and that's an involved one. So are there any questions so far?
I think I'm good.
Cool. So, like we said earlier, everything that makes it to content addressable storage, we assume is all checked out, everything's good. So this is a pretty important step. All right, so basic stuff. Hey, if there's no digest, what are we validating against? So all this is basically is that we're hashing the content with the algorithm and seeing if it matches the descriptor that the client passes up at the end. So I should care if the file is not actually present for the reader. Directory size. Yeah, so we're just getting the stat. So that's just the file information. So it's possible to get a zero length manifest, zero length blob. So that's why that's there. So we're just not gonna explode on that error. So we set the size, and then if it is bigger than 0, then so if the descriptor size is not the size, so we stat that file and we get the goodness, where does the size come from?
Is a file size from the stat or and the one coming from the descriptor? Okay, so we
commit with the descriptor. Sorry. Yeah, so we get a digest and we get a size. So if the descriptor size is greater than 0, so they gave us a size, we'll say like, hey, this should be the size that we found on disk. Or maybe it's 0 or negative, so we don't assume that it cares about the size. Yep. This is not the easiest part. So zoom digest. So if the canonical algorithm, so that's the algorithm of the Blob Writer, does it, if it matches the same, we'll set this verified to true. If we do a different algorithm, we're going to have to download and rehash the uploaded content. So if we're not using resumable digests, we'll have to hash the full content, or there's an error from what's else there. Oh yeah, so that's there's some sentinel errors here and about. So if it's full hash, then we have to download the blob and rehash it. So let's see, if the written size and the algorithm is the same and it's verified, okay. So it's like, if we were around for the entire life cycle of this upload, we can take this shortcut. But if we can't check on file size, what we have to do is we have to read the file completely from the backend. And this is going to be from the upload path. So we read the complete file. We copy it to the verifier and see if it's verified. And that's just going to, yep. So there's a lot, this is really hard to get to really grasp in like a quick survey like this, but it's possible in a blob upload that we have to download all the data from the blob backend and rehash it. So that's a possibility. But that's how that works. And then we check and see if we set this verified flag at any point. If we didn't, we just say, hey, it didn't work out. Canonical digest does not match provided digest. And we turn an error and just like, hey, it's not a good digest, doesn't work for us. And then we just, set some metadata and get it through. So yeah, unfortunately, that's just really not the easiest to understand. And I don't want to dig too far into this just because, the verifier is like, where does that come from? Right, it's part of like open containers, go digest, And then, so you can feel free to dig in that, but there's a library that verifies it. So we do have a bit of an extra time, so let's try to go over cross-repository blob mounting, which I've said right on the first time. So start blob upload. So we go back to start blob upload. And actually, let's go and look at the request flow and go back up to, yeah. So let's say we check for the blob doesn't exist. We can mount, we can do this mount thing. Mount is the digest and from the repository. So digest of the blob, repository that the local client knows about that blob. So this would be like if you're trying to upload a blob to Alpine with the digest of A, you could say like, I know digest A is also an Nginx. So keep that in mind. It's about client knowledge. That's the important thing. And that's decided with like local data on the client, Because people will ask about that, and it's very confusing and it's very scary if you see mounted from super secret repository to customer repository, but it's fine. So here we have like the from repo, and the mount digest. So, hey, if these are both set, we should create a blob mount option, which is we parse the digest. We make sure the repository is a good repository that is properly formatted. They didn't just put like some random characters that we don't, it's not could never be a repository. We get make sure the digest is the right digest for that repository. So, and then we have with mount from canonical. So that is just sets up this little, should you mount? Yep. What should you mount from? This the reference that we gave you. Nothing exciting. So it returns that option. It's just some data storage container. So we have that, and let's see. All right. So we pass that option to create, and then if the error is error blob mounted, so that's a sentinel error, it's not really a real error. Ignore the database stuff. Then we go write blob headers, just like we do all the time, like every place. So that's the end. It's that's the end of the function basically, if we do a cross repository blob mount. So let's get into the create then. So we revisit this. And hey, ops mount should mount. Yes, we should mount because we should do it. It was determined that we should. So we'll do LBS mount. So you can provide it with a stat already, and we'll do this for the database. And that just skips this. But if we don't, we get the repo from the source repository, and we get the link blob store, and we stat it to make sure it's there, it has access, everything's good. And that's basically the whole thing, right? That's, hey, we statted it, it's there. It's known to that repository you said you thought that the client said it's there. We checked it actually is there, and it's on the storage backend. So we give the stat size. We give the media type, which for blobs like this is always going to be application octet stream. We give the digest, and this is a little gross, but we return the digest, but we also return the result of linking the blob, right? So that links it to that, and that kind of does all the work, right? It just says like, it writes that layer file that we saw again in pass, and just to illustrate that again, all it does when you cross repository blob mount successfully with the file system is you write this path. You write this path with the algorithm in the link file. That's really the only action you take. And that's all that that repository needs to know about that blob. So we've mounted, let's say it did well. Upload, and that's when we didn't get so this is what actually return an error. We'll return the error like blob mounted, error blob mounted. Right, so, and that's just a simple error. So we write the headers, we go about our business, and that's about the size of it. Do you have any questions? Anything I should go back over and treat more carefully? Anything like that?
No, I think it, yeah, from the overview, it makes sense.
Yeah, I mean, yeah, okay, go ahead.
Yeah, no, I mean, this is, in a sense, it's straightforward, walking through the code. Like going into the details, that's the interesting bit. Yeah, I'm sure it's gonna take me a bit of time to get a full grasp.
And these are, I'll upload this probably tomorrow, which is so I'll upload this tomorrow, and so you can always rewatch it, probably at double speed. And you can always review it. And I think the intricacies of this took me a long time to grasp, just because a lot happens here. There's a lot of I would encourage you to look at the validation step more in depth in a way that's just not appropriate for this video, just to sort of know when that's going to happen. And most of the time it is, I believe. I think for one of the ways that it skips validation is like, hey, were we around for the entire upload of this blob? And it's like, probably not, right? We probably weren't here for, like, it probably wasn't the same handler for the entire 20 gigabyte blob somebody decided to upload. So, and that's if you look at our monitoring and you look at the memory usage, you'll see these, like, it spikes up and down, and that's what that is, I think. I hope. that would be the most comforting explanation for why that happens.
Yeah. Are these handlers like unit tested, or do we have some sort of integration or end-to-end test or whatever?
The answer is yes.
Yeah. So I could potentially just walk through the test and see what are we testing in there, I guess, or what is expected.
Yes, you could. So there are tests for this. We use let me share my screen again. I didn't get into this too much because participants can now see your application. Test. Blob Writer test. So this is the Blob Writer test. So you can look through that. They're pretty high level. They're okay, but so this is going to be handlers API integration test. these are the most comprehensive tests we have. It is almost 7,000 lines of tests and helpers, which we're moving out to a special helpers file. But so we have this series of API conformance tests that we run against different environments. So we'll run this with the database or without the database. And what do we do? So we do without the database, with the database, with file system mirroring, with some of we can't do now for reasons. So if we do run it with the database, we'll do it with the migration enabled and file system mirroring disabled. We'll do it with migration enabled and without like a, what's different here? Oh yeah. So we'll do it with mirror FS enabled and disabled. And there's other things that we can do here. That's complicated. We run them in random order, but these are the tests that are just like, no matter how we've configured this registry, because like I said in the previous talk we had, we basically have two registries overlaid on top of each other. But we really have three registries overlaid on top of each other because we have just the file system metadata, we have just the database metadata, and we have a migration, right? Mode where we're slowly moving data over. And you'll be around for all of that, so you'll get really familiar. So these sort of say like, no matter, these tests are for like, no matter what, this has to happen. These have to be identical. So, and there's a lot of these, I hesitate to like get too deep in these because like there's pretty, they're pretty high level in a way, because like, we'll see the manifest and push it by tag, and that like, that's all done because we have a helper for that just is like, does all the stuff because we have to do it so much in writing these tests. And then we will, just make the HTTP request against the, the environment that's running in this test, and we'll, check the response. We want to see these kind of error codes. We want to see all this kind of stuff, but they're super high level. So it's kind of hard to take these tests and like step through the code execution because they're very broad, but they don't break very often if they're not supposed to. So they're not very fragile, and they've caught numerous things over the years. So I'm very proud of these, at least. But as far as like, I can use these tests to understand what the handler's doing, not so much. You can like get your expectation. So like, what if you get a Schema2 manifest by digest and it's like, it's not associated with the repository? Like, you should get, not found status and error code manifest unknown. And so that, and so you can kind of like figure out how that would happen, I guess. But yeah,
I guess these are the tests I never want to break. And if I break them, like, when I started working on things, it's the ones that should be like, I don't know, maybe the most important.
Yeah, these are very important. These are extremely important. Really expanded a lot on these because they're so broad, and they're just like, when I do this, I want this back, right? And rewriting the metadata subsystem completely for the database is completely different than the file system metadata. that was one of the things that was super valuable to me, was to say, you know, we have tests that are high level enough to say, like, even though there's a completely different code path being taken for the most part, everything works out at the end. So that's the way the reason these tests are like this. So
yep.
These are fun. These are interesting. These are probably pretty fun to write by now. They used to be quite kind of a pain because we didn't have they used to be not broken out like this. There used to be like test manifest API, the end, and it tested the manifest API, all of it. And so it was like a 1,000-line test.
Yeah.
And it's like, well, that failed. It's like, great. I'm not surprised. Yeah, so let's just stop sharing if you're following along at home. Thank you.